Aspirin can be produced by reacting salicylic acid with ethanoic anhydride. An incomplete method to determine the yield of aspirin is shown. Okay, let me go straight to A and then we'll come back to the instructions. So describe the instruction that is missing from step 4 and justify why this step is necessary. So we had 6 grams of salicylic acid to a weighing boat. We placed the weighing boat on a 2 decimal place balance to record its mass. That's the mass of the weighing boat and the salicylic acid. We tip the salicylic acid into a 100 centimetre cube beaker and then we reweigh the boat. So reweigh the empty boat. And the reason for that is it's to calculate the exact mass that has been added to the beaker. Okay. B suggests a suitable piece of apparatus for measuring out the ethanoic anhydride. So let's have a look how much there is. So the ethanoic anhydride. So 10 centimetres cubed, we would need to use a 10, so it's a small one, 10 centimetre cube measuring cylinder. You couldn't use a 250 because the increments are in twos. So alternatives, you could use a 10 centimetre cubed pipette or graduated pipette. You could use a burette. And then C, concentrated phosphoric acid. Well, that's going to be corrosive because it's a concentrated acid. Okay, next part. Complete the equation for the reaction of salicylic acid with ethanoic anhydride. So CH3, COO, C. So that is ethanoic anhydride. And then what we end up over here is the carboxylic acid. Okay. And then E, a 6.01 gram sample of salicylic acid with the MR is reacted with 10.5 centimetres cubed of ethanoic anhydride. We have an 84.1% yield. We're given a density, so I can work out the mass from a volume. Here's the question. Show by calculation which reagent is in excess. And then part B, calculate the mass in grams of aspirin. Okay, so which reagent is in excess? So the number of moles of salicylic acid is equal to, mass 6.01 divided by the MR 138, and that gives me So 6.01 divided by 138, that gives me 0.0436 to 3 significant figures, moles. The number of moles of ethanoic acid is, okay, so I've got a volume here and the density, so I need to work out the mass here. So the mass, let me do that over here. Mass of ethanoic acid is density times volume, so 1.08 times 10.5. That's 11.34 grams. So 11.34 grams. Divided by the MR, which is 102, which gives me, so 11.34 divided by 102 gives me 0.111 moles. So this is a 1-to-1 ratio here, so it's as simple as just looking at which one I have the most of. So I have more ethanoic acid than salicylic acid, so the reagent that is in excess is the ethanoic anhydride. Okay, so up to there, there's 4 marks up to there. So 1 mark for this, 1 mark for that, 1 mark for this, and then 1 mark for getting that. So part B, calculate the mass in grams of aspirin that has been produced. So here I have to use my limiting reagent, which is this one. So I'm using that value there. It's a 1-to-1 ratio, which means the number of moles of aspirin will be that as well. So to work out the mass then, mass is number of moles times the MR. So the moles of aspirin, 0.0436, multiplied by the MR, which is 180. And that gives me 6.59 grams. Okay. Part F suggests 2 ways in which the melting point of crude aspirin would differ from the melting point of pure aspirin. So impurities tend to lower the melting points. So it'll have a lower melting point. And pure liquids have a melting point. If you think of water, it boils at 100 degrees C. Whereas when you have impurities, you have a range. And again, if you think of crude oil, which is a mixture of lots and lots of different alkanes, it starts boiling at about kind of 30-40 degrees, but will continue boiling all the way up to kind of, plus 300 degrees really. So it will have a boiling, not boiling this time, but melting. So it'll have a melting range. So impurities tend to give it a range rather than a point. G, crude aspirin can be purified by recrystallization using hot ethanol, which has a boiling point of 78. 2 important precautions when heating the mixture. Well, the first one is ethanol is flammable. So do not use a Bunsen burner. So you could use a hot plate, or you could say that you would use a water bath. Okay, and number 2, you need to keep the boiling point below 78 degrees C. Obviously, if it goes above 78 degrees C, the ethanol will boil away. The hot aspirin is filtered under reduced pressure. A small amount of cold ethanol is then poured through the Buckner funnel. Explain the purpose of the small amount of cold ethanol. So when you filtered it through, it is going to be coated with obviously ethanol, but also some soluble impurities as well. So when you run some cold ethanol through, it removes any soluble impurities that may be kind of coating your sample. And then final thing in here, a sample of the crude aspirin is kept to compare with the purified aspirin. Describe one difference in appearance that you would see between these 2 solids. So as it gets purer, it's probably whiter or lighter or less grey, but also the crystals will be larger, because as they get purer, you've got nothing interrupting that kind of crystal structure as it is forming. Okay, so either of those would do there.